And if you could private chat me the answer as soon as you're done, that would be great. Alright, I'm gonna give you guys a hint. So the first time we split this triangle up, there are 4 triangles, smaller triangles inside now, right? So if we split it up again, then there are 4 of the smaller triangles that can fit in here. So then if you can fit 4 smaller triangles into this triangle, then how many can you fit into these other 3? So the answer is 16, because we can fit 4 into this medium-sized triangle, right? And there are 4 medium-sized triangles in total, and 4 times 4 is 16. Now we have some shapes. How many of these shapes have the same perimeter as the sheet of paper itself? So for those of you that don't know what a perimeter is, it's just the length of the outer edges, right? So the length of this entire box would be, they would all be the same, right? But let's see, I'll give you guys an example. I'll just start with L. At least I think this is L. And basically this, what you want to do when you solve this problem is you want to think about this side that matches with the side of this box, right? So that's equal. And you want to figure out which shapes have the same perimeter. So this bottom side is also equal to the bottom side of the box. But then if we come over to this this bend shape over here, well, see, let me see if I can draw this. This length plus this length is equal to this entire side of the box, right? So then you could say the same for this length and this length right here. And then that is also equal to one side of the box. So the total perimeter of this shape is 4 sides of the box. And the box, that's the same as the perimeter of the box. Actually, I'll go over H also. So if you have H, you have this side, that's correct. This side is also correct. I mean the same. And then you have this side and this side and this side. And that equals to one side, right? But then in this little chunk that's taken away, you also have an extra 2 sides over here. And that would make this H too long, like, right? The sides would become too long, so that would not be right. And I'll give you guys 1 more minute to work on this. Alright, I'll give you guys the next letter, U. So if we have U, it's basically the same U shape over here, right? And it won't work again because even though you have this side, these two add up to make a side, right? This small part over here, that makes a side. But then over here you have some extra parts, and when you add them to this side, it's not right. So then H would be incorrect also. So the answer is 4, and one way you could look at this problem is if the shape takes a chunk out of the corner part, then everything will add up to the right perimeter, right? So over here you have, oops. So over here you have this piece, and this piece, and those two add up to make the entire side, right? And that can be true for every single corner here. So this piece and this piece adds up to one side, and this piece and this piece also adds up to one side, right? So the corners always work. So, but if you only take a chunk out of the edge, it will not. Like over here you have these three add up to make one side, but then over here you have the extra, as I said before. Here's the last math kangaroo sample problem. So it's kind of complicated, but we have 4 buttons. Sad, happy, sad, happy. If we press on one face, can you guys see the text on the screen right now? Hello? Okay. I guess you guys will just be able to, oh, you guys can see it, okay. So we start out with SHSH. Let's say I press the first button, the sad face. So then it would turn into HSSH, right? And what we want to do is we want to figure out the least amount of times that we need to press any button in any order so that you can get all happy faces. And just as a side note, the least number of times you need to press the button in order to get all happy faces is the same amount of times you need to press buttons to get sad faces, right? Because if you just flip this, flip the sad, happy around, then it would just be happy, sad, and you could do the same sequence to get sad faces. And this problem is going to be kind of hard, so I don't actually expect you guys to figure it out. But if you have found a way to do it, then that's good too. So now I'll share with you guys. Two people have gotten the answer so far. So now I'll share with you guys how I got the answer. So I just immediately took to figuring out all the possibilities. So here is if you flip 1, this is what happens if you flip the first button, the second button, the third button, I think. Yeah, that's the third button, and the fourth button. So clearly from here, after we press one button, it's not gonna get to all happy faces, right? These are all the possibilities and none of them are all happy. So, and then if we think again, none of these can get to all happy in one button press, right? Because the only way I think you can get all happy is you need like happy, sad, sad, sad in order to get all happy. Or at least that's the simplest way. So let's look at sad, sad, happy, sad over here. Or any of them is fine. But one of the middle ones would probably be the best, right? So what you can do is you can just press the last button over here. And press this last sad, and you can get SSSH. And then from there, you can just press the second button, and that will flip all of them. You could do something similar over here for HSHH and get H. Oh. You could do that. Press the last button, and you'll get HSSS, which will also lead you to all happy. And then for the first one and the fourth one, it will be a little harder. And I don't really think you can get to 3 button presses. Oh, my screen froze. All right. Why does this always happen during math? doing some fun stuff. Oh, okay, actually that was not the last problem. So the answer to this one is 4. I'll just skip the explanation for now, or you guys don't need to do this because I kind of want to get to the next activity. But it's just a levels 1-2 hard problem, so you guys should be able to do it. So we have a dog plus a cat plus a monkey is equal to 12 pounds. One cat and two monkeys is equal to 10 pounds. A dog, 3 monkeys equals 2 pounds more than a cat, a dog, and 1 monkey. And we already know that a cat, a dog, and 1 monkey is 12. So 2 plus 12, and that is 14. So over here, if a dog and 3 monkeys is 10, and is 14, and a cat and 2 monkeys is 10. Well, how much would a cat weigh? So, if we subtracted 2 monkeys from 3 monkeys, and a cat from a dog, that would not work, right? So does anyone have like a good idea of the next step? You can share it in the chat. Alright, so when we're trying to figure these things out, usually we want to isolate one thing by itself. And in this case, we should look for what has this equation over here and this equation over here. Right, so this equation has a dog, a cat, and a monkey, while this equation has a dog and 3 monkeys. And the first thing we would look at is what would happen if we subtracted one from the other one, right? But what we would get is we would get dog minus dog is no dogs, right? So that's 0. And there's no cats. So if we have D plus C plus M, and from that we subtract 1 dog. What we get is no dogs. We would get 1 cat, and we would have negative monkeys, right? We would have minus 2M. Now, what does this look really similar to? This looks really similar to the cat plus 2 monkeys, right? So we could use that equation. We could add these 2 equations together. So C minus 2M, 2 monkeys, and then you add that to C plus 2 monkeys. what we get in the end is the two monkeys, they cancel out, right? So we would just get 2 cats is equal to 8 pounds. If we cross out the 2 monkeys. And then if we just divide both sides by 2, we can get 1 cat is equal to 4 pounds. Alright. The next problem is another levels 1, 2 hard problem. So Anna, Peter, and Jack go to the same school. One day the librarian asked them, guess how many books we have in our library? So Anna says 210. Beta says 1998. And Jack says 2015. And then since this is a limits problem, it's about kind of like distance from each other. I'm gonna actually put them into from lowest to highest. And then the librarian says that they differ by 12, 7, and 5. Right, so this is not necessarily the right order that they made their guesses, right? So maybe Beta was off by 7, maybe Anna was off by 7, maybe Jack was off by 7. And now you have to figure out how many books there are in the school library. And everyone should just be working along with me here. So the first thing you might do when you see this problem is you might just add the biggest number to the smallest, the middle number to the middle number, and smallest number to that. But what ends up happening is you get 2010 over here, you get 2017 over here, and you get 2020 over here, so they don't match up. So clearly that does not work. Now the next thing I would do is I would just take this biggest number and put it on each of these numbers. So you can't put 12 on 1998. You can't say they were off by 1998. Because then it would go up to 2010 and you would have to add or subtract 5 or 7 to 2010. So 2010 would not be an option. So adding 12 is not possible. Subtracting 12, you can't subtract the biggest number from the lowest number, right? The biggest difference from the lowest number, because then these two numbers can't reach it, right? 2010 won't be able to reach 1986. So clearly 12, the difference of 12 will not be on 1998. Now let's go to the largest number. And again, you can't add the biggest difference to the largest number because then 2010 and 1998 can't catch up to 2027 using 7 and 5. And if you subtract 12, we get 2003, and if you subtract 7 from 2010, you'll get 2003 again, and if you add 5 to 1998, you can also get 2003. Oh, I think I froze again. I'm back. Now we'll move on to the 24 game. This is what I was trying to get to before. And if you don't know the rules of the game, what you have to do is, I'll use 3, 4, 5, 5 as an example. Let's see, annotate text. So there are 4 numbers on each card. So here we have 3, 4, 5, and 5. You cannot use the same number twice in a row. I mean, you can't use the same number twice, and you can use as many operations as you want. So you can add 5 and 5, you can subtract them, you can divide, or you can multiply. So, and then what you want to do is you want to use these 4 numbers and get 24 using all of the cards. So, to get 24 with 3, 4, 5, and 5. Let's see. Well, if we multiply 3 and 4, we can get 12, but you can get 2 from 5 and 5. 15 and 20 won't do a lot of good. And basically, you just want to get 24 from all 4 numbers. So let's see. Oh, alright. So what you would do is you would multiply 5 and 5 to get 25. And then you would just subtract 4 minus 3. So that would be equal to 25 minus 1, which is equal to 24. Does everyone get that? So now you guys can work on, let's see, 1. The next one is 1, 1/2, 5, and 10. And just private me the chat, private me the answer chat when you're done. This will help you guys with your arithmetic, and like your problem solving skills. Has anyone gotten the answer yet? Alright, I'll just tell you guys how to do it. Basically, it's really similar to the last card. You want to take 10. I froze up again. Alright, you take 10. You multiply it by 1/2 or 0.5, and that will get you to 5. And then you multiply 5 by 5. It's equal to 25, and 25 minus 1 is 24. Now you guys can work on the other two, which is 5, 7, 8, 9, and 2, 3, 4. Did Anna or Nicole get an answer? All right. Well, for 5, 7, 8, 9, if you go 9 minus 7 is 2, and 5 minus 2 is 3, and 3 times 8 is 24. Right? You can use that. Or you could say 9 minus 5 is 4, and then 7 minus 4 is 3, and 3 times 8 is 24. So there's a lot of ways you can get 3 out of it. Over here, clearly 2 times 3 won't work because then you have 2 4s. And what you can do is you can try to get 8 from 4, 4, and 2. So 4 divided by 2 is 2, and 2 times 4 is 8, 8 times 3 is 24, or 4 times 4 is 16, 16 divided by 2 is 8, and 8 times 3 is 24. I guess that's the end of class for today. And I think that this is also going to be the last class in total, so there's going to be no more Math Kangaroo from now on, okay? So don't go to the Zoom link next week. See ya.